Welcome back, everyone. My name is Matt Levin from the One Connection Media Group here in Columbus. I'm a member of the Ohio Broadcast and Multimedia Technology Conference Planning Committee. Our next breakout session, titled Private or Public Cloud, your rack room is going there, will be presented by Kirk Harnack with the Telos Alliance. Kirk is a senior solution consultant and brings more than 35 years of hands-on experience in broadcast engineering and education to his position. His expertise is putting technology to work in broadcast facilities, has driven notable expansion in IP audio, VoIP for broadcast, and other new technology adoptions by audio content creators. Kirk maintains an active hands-on role in broadcast engineering. He's a member of the board of directors of the Society of Broadcast Engineers and is program chair of the SPE Chapter 103 in Nashville. He founded and hosts the Internet Video Netcast This Week in Radio Tech, or TWIRT, a 1-hour weekly video netcast with regular contributors and guests from the world of radio engineering. And I've had the opportunity to be on your show once. Yeah. The Telos Alliance is a longtime sponsor of this conference, including our lunch today, and Kirk has been a frequent presenter, so we're delighted to have him here with us again. Please welcome Kirk Harnack.
Did I write that delighted part? Thanks, man. Appreciate it. That transmitter pack mic seems, the live mic feeds back. So let's see if I can do that. Oh, yeah, okay, that's good. Can y'all hear me good? All right, recording level's going to be good, as far as we know? Okay. Look closer, really? All right. So today I'm going to be talking about something that Telos, my employer, doesn't really have a product line to sell about this. I'm talking about stuff that's in the future, although we're definitely on the path to doing that. There's some things we can do right now to virtualize what we're doing. And I'm going to take you through a little bit of that. Yeah, that's me like in France in, when was that? 1987? Oh, well, that says 1992. Really? Okay, I guess it was 92. Man, I've aged so much. The point of this picture, though, is that every device that you see in that rack there was purpose-built to do what it's doing. Purpose-built. And we've had incremental improvements in purpose-built equipment over the decades. So, the turntable there was, machined and lathed to do one thing, and that is to play records. Same thing for the audio console and the other metering stuff. And it was then we got cart machines here. So we have carts, but the only thing that a cart machine could do was play carts or maybe record carts. Point is, it was purpose-built. You couldn't play a record on a cart machine. And then we did see some more things happening in the mid-'80s. Steve Church, founder of Telos, started using DSP, digital signal processing technology, in a telephone hybrid. And that was the very first use of DSP in a broadcast product. In fact, when Steve Church prototyped to see, hey, can I make phones sound better? He used a DSP chip from Texas Instruments, and it was one of only 5 chips in the US at that time. He got hold of one. He was very careful with applying voltages to it and writing code for it, and found out that he could make a telephone hybrid operate fantastically. But the other pieces of gear around there are very much purpose-built. Nowadays, though, things are quite different. We have things that are kind of a hybrid, right? So you have an automation system that is running on a general purpose computer, but the automation program, of course, is designed to do just that. We have audio consoles that, they look like audio consoles, but the engine that's running them is more of a general purpose computing device. Remember this? Boy, that was one of the very first automation systems. Is that the DCS system? Anybody recognize that? From Tuscaloosa, Alabama, or no, from Opelika, Alabama. DCS, isn't that where that was from? No, that was from Kansas. Anyway, all ancient history. Remember, though, when the first multi-track editors came out? So I was doing contract engineering in the Memphis, Tennessee area, and I was installing computers that had 386 processors in them that could kind of almost sort of barely do software audio workshop. And we'd have the best sound cards we could buy. I forget what brand they were, but they were a far cry from what we have now. But this was one of the first uses of making a computer do something that normally we would have done with something else, like multi-track tape, right? Well, this is Iwan Roos. Iwan is a colleague of mine. He is one of our software developers at Telos, and he's been highly involved in taking CPU, computer technology, and making it do stuff that we had previously done with, as more purpose-built equipment. Ewan says that the time when it became possible to do, that is the weakest laser I've ever seen in my life. Wow. Right there is when multi-core processors were introduced. And that is what enabled Ewan and thousands, if not hundreds of thousands, of other software developers to start making computers do things that we used to do in real time with hardware devices. So as computers and operating systems moved along, we could do more things with them. Even up until the late 90s, early 2000s, phones were still phones. Even though we had phones like this one, they were still pretty much just voice and text. But nowadays, we have phones that really, really do other things. So supposedly, everything on this Radio Shack ad page can be done. The same functions can be accomplished with a phone. And back when you could buy an iPhone for $200 for the cheapest one, I guess this graphic was valid then. But point being, even if you spend $800 or $1,000 for an iPhone, you're doing what it used to cost over $5,000 to do, at least in 2013 dollars. I probably should update that graphic, but that's the one that I could find to make this comparison. And we've seen that kind of comparison before. So the Telos 10, the world's first broadcast product with DSP. We already discussed that a bit, but that was kind of the beginning of taking a general purpose device and making it do our bidding. Here's a great example from the late 80s and 90s. Broadcasters started using digital audio workstations. There was I want to say it was a 286 computer inside of that. And the developers of this audio workstation, this was called the Odyssey, right? Or the DSE 7000, had a couple names. Orban built these for a long time, built and sold them. In fact, one of my colleagues at the Telos Alliance was like the project guy behind all this. They had to work really hard to persuade that little computer to be a digital audio workstation. It was really tough. It's not nearly so tough today. So PC-based automation systems, of course, came along through the years. The point is we started getting more and more things, general purpose computing devices, doing what purpose-built stuff used to do. Now, this is a screenshot I took a couple of months ago of one of the computers at my radio stations. I'm part owner of 14 stations. I really do own the part that doesn't make any money, which is why I work for the Telos Alliance. But on this computer right here, we're doing silent sensing on 5 stations using a free bit of software. And we're also encoding, we're processing, audio processing, and encoding streaming audio and doing metadata for, I think, a total of 5 stations, although I've got more encoders going for some experimental purposes. What you don't see, I didn't put on the screen, is the IP audio driver that's taking live wire audio over IP from our network and presenting it to this Windows computer, and I can do 24 stereo channels of audio into this computer. So some of the same inputs, if you will, from the network are driving the Pura silent sensors and also driving the streaming encoders and processors. Well, now, if any of you have ever played with any of the software products like Stereo Tool that Matt Levin represents here in the US, or Breakaway processing, this happens to be called the Omnia SST. So this is a full FM processor that runs on a PC. So we can virtualize that. We can actually run this, if you want to, in a virtual machine, kind of further virtualizing it. Because on the one hand, if you've got a desktop PC running a piece of software with audio input and output cards, okay, you've replaced an audio processor, but it's still an audio processor, and it's got a different box. It's a PC box. You can virtualize this further by running all that in a VM on a bigger, more powerful, perhaps more reliable, more backupable, and more duplicatable piece of gear, that being some virtual machine instance. And then you can get in and out of that with audio over IP, whether it's AES-67 or LiveWire or something else. And then we can even take the stereo generator that is in this product and export that over a protocol like micro MPX. So this is the multiplex stereo baseband signal coming out as IP packets, decodable by a Raspberry Pi connected to your FM transmitter. And there are things that are a little stronger than a Raspberry Pi coming along too. Point is, now this is all fully, you can put it fully in a virtual environment. Stations are doing things like multiple codecs on a PC, so just lots of in and out. Well, the folks at the BBC, a few years ago, actually it was probably about 8 years ago, discovered that they were having a real problem. And that problem was they had 40 local stations, that is, stations in local towns across England that were really getting long in the tooth. Their old analog consoles were breaking. The furniture needed to be replaced. I've been in a couple of them, and they were pretty good examples of well-worn radio stations. Well, the BBC, even if they threw a lot of money at this, they were going to have when they refit, when they rebuild a studio, they do a really good job. And the way they do it was going to take months per studio. Now, you've probably been involved in some projects where you've had to kind of rebuild a studio overnight or over a weekend. They don't do that. They take a good deal of time and do it right, but they didn't have that time. By the time, it was kind of like steam cleaning the stones on a cathedral. You start at one end, and by the time you get to the other end 20 years later, it's time to start cleaning the stone on the front end of the cathedral again. Well, they were going to have that problem. They have 40 local stations, and each station has 2 studios. They had 80 studios to refit. And what they decided to do was look for some alternatives. How could we refit these studios more quickly, and how could we get a situation where we didn't have to replace racks and racks and racks of gear at each station? Could we maybe put our infrastructure somewhere else? So BBC went about this VILOR, virtual local radio, and I'm going to show you just about 40 seconds of a video here that BBC circulated within their ranks to explain to their own people what they were doing, and then I'll tell you a bit more about it.
It's virtual local radio, and I'm standing in front of it. This is one of the 2 engine rooms that's going to power local radio into the future. This is in Birmingham, the other one's in London. In the stations, we're going to remove several hundred bays of ancient kit, and instead in the studios you'll have software and control surfaces that will remotely control the equipment behind me. Along the way, we've done a pilot in Radio Northampton. We used it on air for about 165 hours with no major on-air incidents, so we know it works.
So what we have here is a 3-column design. You've got phone lines coming in and out, so this is all the telephony for the studio areas.
Okay, so let me see if I have any pictures of that. I don't think I do. Yeah, okay, I had one. So this is a refitted BBC local radio studio. This was in Kent. I visited there a little over a year ago. And in the studio, they have an Axia Surface. They have some input-output devices, some nodes to convert mics and headphones and such into IP. In this particular design, they also had a small analog mixer that they used to create their own local mix. But basically, they sent then what I would call a super mix minus. That is, everything that has to get mixed together up to either Birmingham or London or both. The actual mixing engine for the Axia console is not at the station. It's 100 miles away. In this case, well, they have 2 studios. One mixing engine is in London and one is in Birmingham. So they have a lot of redundancy going on there. So obviously there's some distance there, there's some digital delay. So their local mix they hear in their headphones is just mixed locally. Now, by the way, now they're getting rid of in their new builds, they're not doing the analog console anymore. They're using one of our X nodes to do the mixing locally, so they don't even have to have an analog piece of gear there. But this was designed, like I said, 8 years ago. Point is, the audio codecs that they use for reporters calling in, their telephone hybrids, the whole telephone system, their automation systems are all not here. They're all in London and Birmingham. Now for the presenters on the air, they don't see any difference. They just know they got some new kit, as they call it. They got new headphones, new mics, and a new mixing surface. On their screens, they see telephone hybrids. They see, the call screener is here, but again, the hybrids are all elsewhere. And by the way, the hybrids are dynamically assigned. So this station has, phone numbers that local people know to call to talk to their favorite talk show, but the hybrids are dynamically assigned. So they didn't have to buy like a Telos phone system for each station. They bought about 10 Telos phone systems, and those have resources that are allocated dynamically among 40 radio stations. And it took our partner in England to write some software to dynamically allocate that. But the presenters don't know the difference. They see somebody calling in, and they have the phone number. If it's been screened, they have their name. If it's in the database, they have their name. And they just answer it on the screen and fade it up on the fader. So again, the presenters don't know the difference, but in the basement of this building, there's literally a rack and a half of gear. And in London, supporting this is one hardware CPU blade that's in a cage of others, and then there are some virtualized pieces of kit, if you will, that's being the whole radio station. And this was really the first effort at making this happen. So we're more sophisticated with this now. We can now virtualize virtually everything that they're doing, whereas they were using some real hardware, some kind of military grade hardware at their data center. So back to our stations, right? So I've got some stations. Some of them are in Mississippi, and I know I've got a rack room that is just chock full of individual PCs and fans and spinning hard drives and power supplies. And if I just have, if just 2% of that fails every year, I've got a couple of off-air emergencies. We're small stations. We don't have much money at all. And in fact, when we built our Rivendell system, all of our computers were off lease, believe it or not, from Walmart, from a Walmart reseller, and they were an average of $218 a piece or so for these desktop machines. And of course, you buy a machine that's already 3, 4, 5 years old, it has that much less life on its hard drive. But that's what we could afford at the time. Well, instead of having all these hard drives and power supplies and fans, we can move this into a more virtualized environment. Now, I am not the expert on virtualization. We're doing some of this at our stations. In fact, almost half of our stations now are running in VMs in terms of course, the automation system, the Rivendell automation systems we're using, in terms of the programs we have that do ingest. That we have one called WebGopher, and of course there's Mr. Master. A lot of you may be familiar with Mr. Master. We have a program, WebGopher brings in our weather forecasts, twice an hour updated, brings in our newscasts, reassembles, rejiggers newscasts every hour for our different stations. But all this stuff is running in virtual machines, and they're all backed up, and as soon as we can afford it, backup hardware will be there too. So we can not quite instantly, because we can't afford that, but close. We can be back on the air if one of our machines dies. The other cool thing about, and if you're in the IT, if you're in a big station, you already know what I'm about to say. I didn't know that server hardware was so darn robust. I mean, to take a Dell, what is it, R710 or R720 machine, an off-lease machine, and just look at the way it's built with dual power supplies and dual processors and tons of RAM and lots of rated hard drives. I was amazed at what you can buy for $600 off lease, cleaned up and looking good. And the hardware is so much better than individual workstations and individual PCs. So I'm feeling a whole lot better about our cheap little operation. Now the next thing I'd like to do, and what I'm going to tell you about here, is I'd love to even offload all that. I'd love to have a situation where in my control room I can have what looks like an audio console, either a virtual touchscreen or a physical console, and pay somebody else to operate my virtual machines somewhere else, and have maybe 2 internet connections, a couple of fiber connections in our town. Well, here's an example of somebody that's already done this. Some of you may know Alex Hartman. He's on Facebook all the time, posting stuff he's doing in broadcasting. Alex works for a company called OMG. You remember what that stands for? Optimized Media Group, OMG. That's right. They're in St. Cloud, Minnesota, and Alex has done a lot of work at the university in St. Cloud. Well, he had a project to build up like 17 radio stations, although I hear that What he's got in this rack is now actually running 30 radio stations. So what you see right here in this rack with the network attached storage and a couple of servers, there is one piece of kind of dedicated hardware. It's the silver one. That's a streaming computer. Oh, yeah, that's a streaming PC. There's traffic and billing is here. Up to 30 automation systems running right there. 30 different formats. Mixing engines for all of those. Codecs for all of these in the form of the streaming computer. What else is in there? He can remotely, or in the same building, he can attach any of about a dozen studios to any one of the mix engines in here. So he could take some students to a room, tell the touch screen in that room, or the physical console in that room, and actually a console, go attach to station R. And station R is one of them that's in there. And then they can run that station manually as opposed to it just running on automation. So all of this is in. Now, all this doesn't have to be in the same building. This could all be off-site. So that's an interesting prospect to think about. Now, you may be thinking, well, yeah, but if something fails, there's a lot that fails. Yeah, if something fails, you may have 30 stations off the air. That would be really bad. But because of what VMs are and the way the hardware world is geared toward that, it just costs money, but you can totally back the whole thing up and even have systems that fail over in a matter of milliseconds. That's what our banks are doing. You know, that's what certainly Amazon and plenty of anybody that's using the Azure cloud or other cloud services, you can get that kind of backup reliability. Here's a station in Italy that is, boy, it's about 12 years old now, but the point here is that we can now remote control consoles with a touchscreen. You've probably seen examples of that. And the last part of my message here is really that virtualization means different things to different people. You know, I mean, think about it. The presentation I'm giving to you now is virtualized. We used to have those overhead projectors with the prism and the lenses and the light from the bottom. I mean, I could be flipping transparencies right now, right? But I have this Mac, which also does Skype and word processing and email, and I'm showing you a presentation. So you could do something as simple as just virtualizing a console, or you could do something much more complicated. This is Sergei Sokolov. He's our dealer in Russia. And he's a big believer in virtualizing stuff because of its flexibility and ultimately its reliability. Here's a quote from Sergey. The main advantage of virtualization is the increase in reliability. For example, the Axia Studio engine can be quickly moved to another virtual machine. This is the easy solution for backup. The second advantage is the efficient use of hardware. To each virtual computer, we can give exactly how much power and capacity we need. The third advantage is simple scaling of a system. Reliability is one of the advantages of virtualization. However, a reliable platform for virtualization is not cheap, he says. And indeed, to do this properly, and I'm not an expert at doing it properly, you certainly can spend some money. But what we're going to spend on building 12 studios anyway. So I think it's balancing out right now. There's the glass user interface. So when considering broadcast operations using a glass interface or touchscreen, it's natural for people to point out, well, users want real faders. In fact, we had this conversation at Telos probably 10 years ago. Users want real faders. They won't like dragging a finger or two across a touchscreen. And for quite a few years, console manufacturers have agreed with that. But some forward-thinking users have been working with console makers on creating easily workable multi-touch touchscreens. The user interface design is critical, and much design usability testing is done to produce some satisfactory results. Well, one engineer, and this is Alex Hartman, the guy I was talking about earlier, he's working with college students and younger broadcasters on researching and adopting touchscreen interfaces. After gaining a lot of hands-on, he notes, the glass interface of the future is meant for those who have to use it day in and day out. It's not intended, and this kind of hurt, it's not intended for the 60-something-year-old engineer who only see it when it's installed or when something goes wrong. He says, not having real faders doesn't bother the iPad generation. So that really hit home with me because I kind of like real faders. So thinking about broadcast controls in the future, will they be all glass? Will operators handle all or nearly all functions on glass screens? Well, it turns out we're already doing these things now. Maybe not in the same studios all the time, but in pieces. So in coming up with this presentation, I was reminded, you know what? Years ago, I worked with Gary Klein at Cumulus to develop what you see on the upper left-hand side there. Gary came to me, like I said, 7 or 8 years ago and said, yeah, Gary wasn't afraid to ask for favors. Gary would say, Kirk, I need to borrow 30 radio consoles from Telos. I said, dude, we're not going to loan you 30 radio consoles. What are you doing? He said, well, Cumulus is doing this Radio Row thing where we go to a country music convention or the ACM Awards, and all the country artists go from table to table to table. Each table is a radio station. They go from table to table to table, and each station gets to do their own interview with, you know, Taylor Swift or Big and Rich or whoever it might be, Florida Georgia Line. And we need a console at each radio station booth. I said, well, he said, and I don't want to put Behringer or Mackie consoles there. I want some broadcast consoles. I said, well, you know, we're not going to loan you 30 consoles. We probably don't have 30 consoles in stock at any one given time. And after you use them, they'll all be used. So, and if we told you what we had to charge to rent them, you probably wouldn't like that either. Let's think about something else. So in the long run, long story short, I remembered that, hey, our mixing engines actually have built in a whole separate mixer underneath. We call it vMix. And it's for doing little utility things. And there's an API for it, and Cumulus owns BSI software. So I said, Gary, you know, our own Pathfinder software comes with little on-screen fader controls to run our vMix. It may not be appropriate for you, though. Why don't you see if BSI can write an iPad app that would, by Wi-Fi, get into the network and control the vMixers on a bunch of mix engines. And one mix engine had 16 vMixers in it. It actually took 2 vMixers to make a headphone mix and a mic mix for each radio station booth. So the bottom line is they ended up buying a bunch of our mix engines. BSI developed the software, and they used this, and they still use it today. They've had to replace the iPads, but they're doing all their Radio Row stuff. All the stations, 30 stations at a time, come in and get set up and do their interviews this way. So on the desk, they have 4 microphones, 4 headphones, and a Telos X node, a mic X node with mic inputs and line level outputs, a little headphone amp, and then, and in fact now they're not even using the mix engines anymore. They're doing the mixes in the X node because the X node can now do mixes. I'll show you that in a minute. So anyway, that's one possibility. Another thing to kind of get into virtualization is from a company called IP Studio, and Telos makes this available in the form of some software called IP Tablet. So you can custom make screens that give you metering or faders or control of headphones and mics or even the phone system. And you can run that on an iPad, or you can run it, on a Windows tablet. That's what that's built for. So anyway, more examples of virtualization there. Here's another example. This is an intercom system, a traditional broadcast or theater intercom system. These are massively purpose-built with these card cages that can easily end up costing over 100 grand by the time you populate them. And it'll do one thing. It'll be an intercom. Now, it's a heck of a good intercom, but it can't be anything else. And then all the stations are purpose-built too. Well, now the clever engineers at Telos figured out we can do intercom over an IP network, and we can make it AES-67, so it'll talk to other TV and radio stuff. And so now, actually, each one of these panels, it's basically running a little Linux operating system in there, and it's just telling the buttons, hey, you're part of an intercom system. So, more example of virtualizing intercom. The user interface is still a piece of hardware, it's still something you touch, but all the back end stuff is using computer technology. So some broadcast automation companies are now offering full broadcast automation systems that can run in a secure data center as well as locally. You can contract with Enco, I believe, to run one of their systems in a cloud. There are already internet streaming providers that let you lease an automation in their cloud, if you want to crank that up. John Anderson here reminds me that Rivendell's next version is specifically designed to be VM friendly. So you can run it on your own VM or in your own data center, or you could probably contract with one of the major data centers or public cloud type of services and run it there, if that's what you want to do. And again, what are the advantages? Well, the advantage for me, you know, fewer hard drives, fewer fans. Let those problems be somebody else's in a controlled environment. We have a hard time keeping our little rack room cool in the summertime in Mississippi. And our stations in American Samoa, we suffer from salt air. I mean, towers don't last very long there in American Samoa. Air conditioners sure don't, you know, with their cooling, their fins outside. So we can now look to putting a lot of this stuff in the cloud, including you know, ingest, playout systems, even EAS. You could, I mean, theoretically put your EAS systems in the cloud, and then you can have all that running in the cloud and using micro MPX over 1, 2, or even 3 internet paths, send the finished product to your transmitter site. And of course, your streaming encoder right there as well. Let's see, I'm going to leave some time for Q&A, and we'll show and tell at the end. I'll make this case here. One of the benefits for broadcasters, you know, more of us have people voice tracking from home. I do my weekly podcast this week in Radio Tech. Now, it's not the quality of a major market talk show, but it's not bad either. But we all do the show, we all dial in from our home using either Skype or a WebRTC enabled browser. It's video and audio. I've got a 1080p camera that points at me, so do my co-host. And, good microphone, good internet connection. The video and audio is all switched at a studio in New York. It's actually in Queens, New York, and there's actually nobody there because the guy who's producing our show lives in Detroit. So he remotes into the studio in New York and switches my TV show. It's crazy. Even more crazy is that the house where in Queens, where our show is switched and produced, Madonna used to live there. So it's just, I mean, it's a weird world. So more and more people are participating in broadcasting remotely. My 14 stations, we have fresh weather twice an hour on every one of my stations, and the guy who does it doesn't even live in the U.S. And it's absolutely up to date. Tornado warning, bam, we've got it on the air within seconds after it was issued by dropping the file into a folder for our automation system. We can actually do school closings. We don't have that problem much in Mississippi. We don't have much snow there. We also do newscasts. Our newsman, our local newsman, actually doesn't live in the USA. His newscasts sound, oh, you know what? I've got an example of them here on the last slide. We'll look at that in a minute. Point is, your talent can really be anywhere, and they can really do as good, if not a better job, than was previously done. Now, I'm not talking about bland voice tracking where almost everything sounds the same. We've all heard that. We all don't like it or don't appreciate it much. So, but it's possible to do some cool stuff. It's possible for sports broadcasters to work, well, I say from anywhere. Obviously, they're working from the game. I say that, but you know what? I was in Australia a couple of years ago, and there are plenty of soccer, football as they call it, or Australian rules soccer games that the sports announcers are not at the game. They're watching a private feed from the television broadcaster. They pay for a private feed that gives them a bit more video. And so I went into a studio one night, and there was a desk like that one, a desk just like that one, set up with 4 headsets and this huge screen TV. I said, what's going on here? I said, oh, the guys can't make it down to Melbourne for the game, so they're going to call it from here. You're kidding me. No, they do. Bang up. Everybody thinks they're there. So, wow. So there's me 15 years ago telling the Australians that they needed to think about audio over IP and doing everything on the LAN and what benefits there would be to that. Here's Jason Ornelas from California. He's one of the SBE board members. He says virtualization makes broadcasters better with branding, control, monitoring, processing. The list goes on. I think the surface hasn't really been scratched at all for broadcasters with regard to virtualization. In a cloud-based broadcasting world, broadcasters get more efficient operations and far lower capital expenditures. And I'll mention that. There's a major U.S. broadcaster, probably not a top-of-mind broadcaster for you, but it's a big outfit. And they buy stations and put in new studios in new cities, and they're a little tired of spending oftentimes over $100,000 cranking up some new studios in a city. They'd much rather spend $20,000 or $30,000, and look, we're helping them do that by having their infrastructure, and a lot of their programming is similar on their stations, not all the same, but they'll be able to just buy a little bit of local stuff, what looks like a console, headphones, microphones, computer screens, a couple computers to talk to the mothership, but all the things that they need and use, are going to be off in a data center, a lot like what BBC does. This is a screenshot I took yesterday, actually, at my house. So what we have here, we have some Rivendell automations. 5 out of my 10 stations are running on virtual machines. There's audio download and ingest for all 10 stations here between Mr. Master and WebGopher. Streaming, audio processing, encoding, conference monitoring, and the stream rendering to go to our CDN are all on here. Audio silence sensing is on here. Audio logging for the morning shows on 4 of my stations are on here. Our business phones, the PBX for 11 radio stations, is all right here. The ones in American Samoa don't have good enough internet to do live telephone reliably. And by the way, here's how virtualization can help you. On Monday afternoon, the server that we use to run free PBX, to do our whole PBX for all of our radio stations, it died. And it's at a data center. And it's a long story short, but basically it's provided to us by my colleague Joe Talbot. Joe works for the Telos Alliance. He's our telephony guru. And I'll make the long story very short. He didn't really have good access to that server. The company that the data centers changed hands 3 times, and he no longer had his good access there. So basically, within 2 hours, he had a new PBX up and running, fiber connected from 2 different sources, in a building that has backup power and dual air conditioners. And I had no backups, and it was a different version of free PBX. So it took me a few hours to get all of our phones back connected again. Bottom line was, though, all of our phones for all of our stations are now, within about 6 hours, we're all redone, reconnected, and the PBX is actually running at Art Bell's former station, KNYE, in Pahrump, Nevada. And it just, oops, did I turn that off? No, I didn't. Okay. So point is, if that was my place, if my PBX was in Greenville, Mississippi, I'd have to tell them I can't drive down there to Greenville until I get back from Ohio, and maybe I can get something back up and running this weekend. So that's one of the benefits of having somebody else handle the good stuff, the stuff that is tough for us to handle. Anything else on here? Oh, yeah. Also, as I mentioned, our news is handled, and our weather is handled on that. So let's see here. That's our radio newspaper, if you will, our website that has local news on it. Our news guy that's out of the country updates that. And let's see if I can...
Jackson, Election Day roadblocks question. Good afternoon. From the Delta Radio Newsroom, I'm Ben Caxton. At 2 o'clock, it's 60 degrees in Cleveland, 57 in Greenwood, 59 in Indianola, and 60 degrees in Greenville, going up to 60 today. The full up-to-date weather forecast from meteorologist Tom Churchill follows this report. An early Election Day fight in Jackson was settled on Twitter, not at the ballot box.
Sorry. I don't know why it's not showing me the icons on screen here. And... I'm just going to have. Point is, that newscast was a fresh one from yesterday. The weather was a brand new fresh one. Both produced essentially out of the country. So broadcasters have been virtualizing various aspects of our operation since audio recording began, but the last 3 decades have seen a steady growth in all this. Some wrap-up examples in the upper right-hand corner. That's a producer's position for a radio talk show on ESPN radio, and that guy lives in Birmingham, Alabama, and produced the whole show from his home. The talent was in Charlotte, North Carolina, and of course ESPN is up in what, Bridgeport, Connecticut? Is that where it is? Bristol, Connecticut, thank you. Just pretty amazing that they were able to people wanted to live where they wanted to live, and they picked the best talent to handle all that stuff. Let me, it's 11:05, it's 12:05. Let me just wrap this up with a video with Scott Shannon and a couple other people in it. The notion of this video is to give you a little bit of an eye to what the future of studios might look like, and that future is made possible by virtualizing the stuff that we have. We really couldn't do what we're going to show you with traditional broadcast gear. So this is just a short little video, and when we're done with this, we'll have a Q&A for a minute, and then we'll go get something to eat. This is, see how this works out here.
Thing is still the same year after year. It's about the individual behind the microphone being able to communicate with the people who are listening online, on their phone, in their car, on their radio.
So we asked the question of a major European broadcaster of what would the talent in the studio really like the future of their technology, the future of their studios to look like. And the answer that came back was not what we or the broadcaster was expecting, but there were 2 clear things they wanted. One was cushions and the other was daylight. Hi, my name is Dan McQuillan from Broadcast Bionics, and today we want to talk about the Bionic Studio. That's the future of radio production, fitting it to reach and retain an audience of distracted listeners, and also helping you to measure and monetize all of those different platforms that radio now needs to reach. So a Bionic Studio means a studio which is listening and watching and reacting to what's happened. So rather than the technology merely being passive, it's part of the production. I mean, if you think about it, you wouldn't hire a producer and then sit them down the hall and have them not listen to the program. They couldn't be much help, but that's basically how the technology has been. It's been passively inert in the studio. But now through intelligent and fast transcription, the studio can react. It can understand what you're saying and automatically detect topics or segment your program. Using face detection, we can recognize who's speaking on cameras to help to generate the metadata that lets us drive more intelligent programming. So a Bionic Studio looks and works in terms of your operation exactly the same as a passive one, but the tools that you're using are able to react in context. You play a particular song, we can react to that song by pulling more information and control into the studio. It's about capturing the very best moments of radio, those intimate moments when the voice breaks and you know a caller's going to cry, when you have something that just has that driveway moment when you can't exit the vehicle because there's that compelling moment. And now I want to make that content shareable and searchable so it reaches a whole new generation of listeners and is discovered in just fantastic and exciting new ways.
My experience in a control room is pretty simple. The less I think about the technology, the better off I am, and the better my show is, and the better my performance is.
To lead in our world, it's all about innovation. It's what's that new, next big idea. Anytime we get to take our content and spread it, that helps us create word of mouth, or as it is now, online digital postings and social, that gives us the greatest promotional tool ever. And that's something we're all trying to embrace.
Essentially, radio is a document. It's just a spoken document, but we've considered it all along to be audio. So by transcribing it, that audio becomes searchable and discoverable, not just to audiences, but to us within the radio station. So we can search for, someone said banana yesterday, that's fine. They said it at 17 minutes past 10 in the morning and exactly this many milliseconds. So it's not just accurate transcription, it's time accurate. So now imagine you can edit your entire show just by clicking on the words or the script within the show. That's actually all you're really doing using a waveform editor. It's just that you're having to map between squiggly lines and what was really essentially a spoken performance or the words that happened. So it makes radio searchable, which is fantastic. It makes it fit for sort of closed captioning, which is the way that now people often read Facebook audio before they actually click and hear it. And importantly, it makes it time accurate so that you can do your job just by clicking on the words that you said, whether that's searching for them or using that as an in and out cue to edit. I think we can create an even more intimate environment for radio, We don't want to get rid of all the technology, but we need to smarten it to a point where it becomes less of a distraction. And I think the whole cushions and daylight idea was, can we actually make this a more comfortable and natural an environment, not just for the talent and presenters, because we're kind of used to this stuff, but I think when we're interviewing people and we're inviting guests into our space, if we were sitting surrounded by cushions and daylight, I think what we would get out of our guests and the way we appear to our audiences would be transformed. There's nothing wrong with the way we make radio. We want to help you to make it smarter and better and fit for all the devices that we now have to hit. So thanks for giving us your time. We're trying to start what we call the creative conspiracy. That's engineers working with talent in the studio to take technology and help really to improve content and have it do exciting things. So if you want to join the conspiracy, you can see what we're up to. Our website is bionic.radio, or hopefully we'll be in touch to find out how we might be able to help you to build a Bionic studio for the future. Thanks for listening.
Every question eats into your lunchtime. Any thoughts or ideas about what we've talked about here on virtualization and maybe leading to studios that the talent is really comfortable in?
Just say that the weak link there, of course, is the network connectivity. If you're in an area of the world that does not have rock solid network connectivity, it's kind of a non-starter.
Exactly. Absolutely. I don't know what percentage of stations that would be. I was in Jackson, Georgia a couple months ago at a teeny station that still sounds like it did in 1982. And they just replaced their transmitter, their original transmitter. And yeah, I'm sure they have one source of internet. But hey, my station's in Greenville, Mississippi. We have 3 different internet providers available to us. One of them fiber, one cable, and one UVerse DSL, which is kind of amazing in Greenville, freaking Mississippi. It really is. I have a transmitter site in a wide spot in the road where I have 4 FM stations. It's called Heads, Mississippi. Literally, there's a farmhouse, a really sweet dog, and our tower site. And we now have 2 sources of internet there. One of them is my own Ubiquity link going there. I've got to crank down to 100 megabits. And now we have a wireless ISP. Our tower is one of his hot points. So we get 6 megs down and a meg and a half up from him, which is, by the way, enough using the micro MPX protocol I mentioned earlier. We could feed all 4 of our FM stations with and do that 4 times under 2 megabits. We can feed all 4 FM stations with beautiful multiplex stereo. So yeah, that wouldn't work for the studio up and down, but our studios, I'm just finding more and more places we can get it. I got 3 fibers going by my house now from 3 different providers. I never thought I'd give AT&T my money, but I just signed up with them for a gigabit up and down.
The other thing you might want
Yeah.
is you really only need to get the big pipe to where your SSL is. There's nothing to say you can't deliver that audio back to your studio and send it out the traditional method.
Oh, exactly. So instead of going from the data center, as I maybe described, to the transmitter, which may be the most problematic place, the transmitter, bring this back to the studio and then STL it to the transmitter site like you do it now. Sure. By the way, there's a friend of mine, Dave Anderson, in Florida, and he's the engineer for the Joy FM network. And all of his stations are, his STL is IP. He happens to be using Telos Zip1 hardware codecs to do that. But he gets 2 internets to every transmitter site, and one of them may be Verizon 4G. Now that's the backup. But and one of them, and the main one may be no internet at the transmitter site. But hey, 3 miles away there's a general store, and that's where the cable service ends, right? So hey, excuse me, how'd you like internet here? We'll pay for it if you let us put a little dish on your roof to shoot internet to our transmitter site. So they've done that at a couple of sites. By the way, if you don't know about it, there's an engineer by the name of Josh Bone, with Bone, B-O-H-N, Bone Broadcast, and he is actually now himself, I forget what you call it, he has a relationship with Verizon such that his company has his own APNs, access point names, on the Verizon network. He can guarantee you throughput on Verizon 4G. Absolutely guaranteed. No matter how many people in the stadium there are, if you have his box, you have priority. At which Verizon always told me that they can't do that. Well, they can, and they do. And now this isn't cheap. It's $300 a month for enough data to put your station on the air 24/7. But there's a lot of options coming up out there, especially if you can take care of the last mile on your own. There's even more options for transmitter sites. I don't know how soon all this is happening. I wish it was. I would love to pay somebody $1,000 a month to virtualize, to host my radio stations in the cloud, instead of me having racks of computers and the place being a 7-hour drive away from me, and no qualified people we can find in Mississippi to even, swap out a hard drive. So, yes, ma'am.
It's also much more secure.
To do what?
To go to the cloud.
Oh, do you mean, okay, so this is Amy Seitz. She's going to be a panelist on our cybersecurity panel this afternoon. And Amy works for a big company that I'm sure gets hit a lot with phishing attacks and all kinds of nastiness. She points out that data centers in the cloud probably are, and certainly have the ability to be, a lot more secure than I can make my place. I mean, we still have a few port forwards in our place, and our VPN is still PPTP, which is known to not be entirely secure. So yeah, let the professionals handle that part of the stuff. And what we make radio best, right? That's what we do. Did I get that right? Okay. Yeah, I would hate to do a pen test on my radio stations. I think it'd be bad. Thank you for your attention very much, and come by and see us at the Telos Alliance. Wish we could sell you this stuff now, but it kind of doesn't all exist yet. And hope to see you at the cybersecurity panel this afternoon.